I'm Jimmy Chang, and we're here to discuss square root procedures. Now, square roots are one of those things that takes a little bit getting used to, but at the end of the day, it really depends on what kind of numbers you have within the square root. So we'll do a couple of examples going forward. Now, suppose you have a square root of 9. Now, 9 is what we call a perfect square. Numbers that have perfect squares are really easy to simplify, so the more of those you have, the easier they are to take care of. Now, being that 9 is a perfect square because you know 3 times 3 is 9, that's why square root of 9 is 3. Because what number multiplied by itself is going to give you 9? It's going to be the number 3. Now, if you have square root of 25, you have to ask yourself the same question. What number multiplied by itself gives you 25? That's going to be 5. Now, one of the things you want to keep in mind here, though, is that you do not really want to have a square root of a negative number because no real number multiplied by itself is going to give you the number on the inside. So, for example, square root of negative 16, it is not a real number. Now, suppose you have something a little bit more involved, like square root of 45. You know that no number multiplied by itself is going to give you 45, but that's not to say that you can't break it up into pieces to where you might be able to simplify it a little bit. Now, one pair of numbers that multiply to give you 45 that a lot of people think about is 9 times 5. Now, when you have a number that's not a perfect square, you want to think about, okay, what two numbers will multiply to give you the number on the inside, one of which will be a perfect square. So, since 9 times 5 is equal to 45, what you can think about is square root of 9 times 5. Notice I rewrote the 45 as 9 times 5. Now, there are some square root rules out there that allows you to break it up into two separate terms. So this will be square root of 9 times square root of 5. Now, we can't do anything with the 5 because square root of 5 is prime, but square root of 9 is 3, so think of this as 3 square root of 5. Now, you can do this for multiplication, you can do this with division, it works the same way, but one thing you cannot do is with addition or subtraction. So, for example, if you have square root of 16 plus 9, you cannot break that up into two separate square roots like I did with multiplication and division. You have to add or subtract the number on the inside. So in this case, square root of 16 plus 9, you have to add the two numbers, so you have square root of 25. But as you know, square root of 25 is equal to 5. So, I'm Jimmy Chang, and that's a brief overview of square root procedures.